Hello and welcome to this explanatory video where I will explain how the Componium composition system scales its mixing agents. So first a small introduction. The Componium composition system is an online composition environment. It has a server, so the server serves a website and then the end users may connect with their browsers to the website so that a composition tool will load in their browsers and they can create a musical composition from different MP3 files. So these files are stored on the server as well as their compositions in a database. So a database has files that create one composition from different MP3 files. Each MP3 file has a position within a larger composition, and together they form that composition. So it has a LAMP stack, a Linux Apache MySQL PHP system, and that serves the application to the end users who connect to the system. So once they store a composition, then they may at a later stage want to listen to that same composition, but then that time not loading it in the composition environment, but consuming it as one MP3 file, so that this system somehow has to create one sound file from the from the composition of multiple. So it has to render them, and we decided that this takes a lot of resources, so it should be done in another system, so that when we have these tasks of rendering an MP3 file, this system resources will not be too much hampered, because otherwise the response time here would be too high, so that these users would experience problems using the browser tool. So in that case we created another system that's going to do those tasks. So this system is going to ask for a task, and then it's going to look what's in the queue of rendering tasks. And if there is a task, it will return the entire task. So that's the description of MP3 files with their positions. That is the task. And then this will render it to one MP3 file. And submit the end result. And it will be stored on the file system of this LAMP instance. Now this is another LAMP instance. It's actually the same software package, and during installation it can be configured to behave as a mixing agent. Instead of a web server that will serve the website. So this is the mixing agent role, and this is the main site. Or rather main application. Now our problem with a growth of the number of users, it can go up, and then the queue will go up as well, the queue length. And then this bottleneck of the system is that this one agent will not be enough. So it has to allocate more resources, and we do that through horizontally scaling. So we have one part of this first agent. The name of such a system is a high availability proxy, and it will look at the number of resources and compare them to the number of tasks, to the weight of the workload, and if necessary it will just create a new instance, so it will kind of multiply, and we have another of those, so then we have two mixing agents. So how does it do that? How will it create? How does it know when to do so? Okay, so here we have the high availability proxy, and it runs only on the first agent. So after it will multiply itself, then this one will not have an high availability proxy, only the first. So it will go to the main server each minute, and it will ask how many agents do we need? How many agents? Wow. How many agents do we need? Then it will reflect on the number of tasks. The queue length. And the task duration. So the main system knows how long it takes for one agent to complete a task, because it keeps an administration of the... It knows how many agents ask these questions and what is the duration between of this, and how often the question is asked. So because of its central position, it also can keep an administration in its database of the... So it can answer these questions, and then it can determine how many agents it will need. So it gives an answer, so many, and then the high availability proxy knows if n is less or equal to the current. If the number is less, it will scale down. If it's higher, then it will scale up. It will remove one instance, or it will add one other agent instance. So then outcome is it will scale. So what do we expect to see then? If the queue length will go higher, then at some point the number of mixing agents that the high availability proxy created will go up, and then we should see that this number of tasks will grow a little less. And if it's even higher, then we see another instance created by the high availability proxy, just as long until it starts falling again, and then it should also at some point remove those instances again, just until, well, we can now anticipate peaks in the number of concurrent users, so that the waiting time for a composition to be rendered will not be too long. And if it's necessary, we allocate more resources. And if it's not necessary, we deallocate them. So here we don't pay for them. We only pay for them when it's necessary. So that's called elastically scaling elastic cloud. Wow, happy. Okay, so now we're going to see that in action. Hello and welcome back. I promised to show you how the scaling system of the composition environment looks like in action. So here you see pretty much what it looks like. When the number of tasks rises, we can see it has here risen up to 5. Then after that, because of the agent is active rendering the compositions, the number of tasks will go down again. And here below you see the number of agents that are issued by the central application. It has been one agent all the time because it starts scaling only after 10 tasks are stacked in the queue. So that's maybe going to happen in this movie, I hope. Let's see what the situation is now. Yeah, I created some other tasks, but they're just not enough to set the scaling algorithm for the number of agents to go up. So one thing that you should know is that the first of the agents does one task per minute, and that is to keep some time empty in order for the high availability proxy to do its work. So it's just not to have the first of the instances too busy, but when you start the second and the third and further, they will be busy with mixing the MP3s a lot more. So they can do 3 to 10 tasks per minute. That's what we're hopefully going to see in this movie. Well, to view real-time data, we can look at our tasks number in the website itself. So this is what currently is the number of tasks. And we also have the current number of the current situation of the application. So here you see that the application has one instance up as of now. Whereas these beautiful graphs, they show the data of maybe 1 minute ago, because they're based on a polling mechanism. So you see that in real time we saw it already should be 8, but this graph still has the old data and thinks it's still 9, so we keep refreshing it until we may see that the number of tasks will go down again. Yeah, there we go. So as we would have the number of tasks above 10, then it should issue for another instance, which is what we'd like to see what happens then. So we just break some other data and see if we can get to that point. Okay, so what is now the situation? We have a number of tasks, 17. Okay, so that should issue one other instance. Let's see if the polling mechanism is already... No, And the polling mechanism also triggers the issuing of agents, so it should be still 1. Ah, obviously it's just started another 1, so yes, we get above the threshold value. But why isn't the graph scaling with us? Why is that? So welcome back. I just had to debug my graphing. It didn't, for some stupid reason, it didn't go above this, but now it will scale up when there's more. So you see the number of tasks that we saw. It's been totally graphed here, and now the completed tasks are decreasing the open number of tasks, which is great, which is what we like to see. So now you can see that the rate at which the tasks are completed seems to be pretty steep. So let's just move on, see if we can get even more agents to be active and to be just as effective as the first 2 agents. We're now going to just have a whole lot of compositions. So we have like 30 of them per page, so there will be 30, 60, excuse me, 30, 60, 90, 20, 150. So if we just put has MP3, update composition, has MP3 is 0 where ID is greater than or equals, okay, go. 117 rows affected, but not all of them are tasks, obviously. So how many tasks have we got open now? 107. So that's should do something. Let's look here. Okay. So it's already issued the number of tasks already gone up, but also here it looks like I have to do some debugging for my graph, so I'll be with you in a moment. So there we are again, and this time it was easy. I already knew what gone wrong, so now we see that 11 agents have been ordered, but obviously these go one by one, so it won't be at 11 yet. We see that 3 have been started now and 1 is new. It's obviously being fired up, and these already running, so maybe we can already see some of the tasks to be completed. It's not going so fast as we would like it to see, because these agents, they need some time to get organized. They need to download some stuff and install some stuff and download some data, so it's got a small delay before they're really effective. So it can happen that it's not going down as steep as we'd like to see. And of course, because it takes some time for them to fire up, we had 3 of them ready. Right now it can be a bit, it's 4, so maybe one will get started in a few moments. So we have to look at how the situation develops. It takes some time, so here we see it's happening. Another one has been started, so we got 4 running and 1 started. And we are on our way to maybe 11 instances, because we got now like a 100 and something tasks. So to be precise, 97 of them. Yeah, so stuff is happening here. We already reached the speed that we saw before. This is looks like there's 2 agents active, like we had here. We have the same kind of decrease in tasks. It's the same situation, 2 active agents, so the rest of them are obviously still in the process of starting up, downloading data, etc. But we're going down with more than 2 per minute now, so okay. It's very exciting, but I'll just... So we're back. I just took some time, a few minutes, and we see what happened in the meantime. So we got 7 of them running. 7 instances now running, and the number of tasks open is 72. So that goes down very quickly. And we probably won't see more than 7. What is happening here? Okay, so this is going it's very nice, because it's much steeper than we saw here. And it will probably still go down even steeper than it did before, because some of them may be still in the process of downloading and installing. Look here, it's even firing up 1 new instance. I didn't think we'd need that. Still, we can look what is the case. Oh yeah, it's at 8, so it could just install 1 other instance, like it's doing here. Let's see, is it running already? Yeah, it goes pretty fast, so now you may see it decrease even more. So all of this happened in like 600 seconds maybe, so that's 10 minutes. In 10 minutes we see that the system could mix down some 60 tasks, so that's 6 per minute. Which is cool for 8 instances, but I'd rather see more. Okay, so this is really promising. Now it goes down faster. So these agents are now really at speed. Maybe it will be faster. than this. So what if we would continue that line? We'll see what the top speed will be in the end. So here we are back again. So let's just look at the number of open tasks. Whoa, it's 0. So what has happened? Guess what? We are already shutting down instances because there were 8. Now there are 7. Also, this goes step by step. So you can take a few minutes before all of them are down. And what's happened here? Bam. Okay, this looks good. Maybe I don't know why it would be slowing down here. Now what I am really wondering about is what this system will be doing when it's because you know this it's probably still busy downloading files here and there that it needs. So after that's happened, then the system will be at full speed, and we only know what that looks like after we do the bigger experiment. So let's just set that up, and then so this is going to generate a lot of tasks. It may be pretty brutal. Yeah, so now we got like 2,000 tasks, and just look how the system reacts to that. Already have a notion of it? No, we're still busy here with the shutting down of gears. We're almost at 1. So there's right now there's 2 gears, 2 instances. So the system doesn't really know what's going to hit it. The next few minutes, see, no, still no notion of it. Whereas if we look at the number of tasks, it's like over 2,000. That's nice. Ah, look, here we go. So it's got like 2,000 and a bit of tasks, and it's ordering 200 and something agents, but well, that's not going to happen because in our OpenShift contract we can have maximum 15. However, we're going to see how fast it will run, how fast it will complete tasks on 15 instances, and well, maybe it's already starting up new ones. Yes, it is. Okay, so we'll just see how this develops and get back to you when the movie gets more interesting. So this is what happened after some time. We see that it's doing about 650 per minute. So we got like 1 in every 10 seconds, which is much faster, but not so much as expected, because it used to do 1 in per minute on 1 instance, and now it's doing not even 16 per minute on 16 instances. So what's wrong here? I don't know, but at least it's scaling to some degree. Obviously some other things don't work out as expected, so it's still a long way to go, sifting through bugs and errors and installation problems probably, but at least we got some success in making elastically scalable task agent. So thanks for watching, and see you next time.